Hello, today we are presenting our local first shopping list application. The application must fully work offline and have local persistence and only go online for syncing. Lists can be created and deleted, living under a unique ID. List items can be created, updated and deleted. Lists can be shared for user collaboration. The architecture developed should be fault-tolerant and support millions of users via high availability at the expense of data consistency. Looking at the developed architecture, we have clients. A network composed of DNS and proxies. A backend of web workers. And database replicas. There is load balancing on the network for resource distribution. The architecture is made to support horizontal scalability to meet high processing demands. When a user first connects, the DNS provides him with a proxy IP to use using round-robin algorithm. Now we can make a full request to the backend where a web worker will make a quorum consensus from 3 replicas. Taking a closer look at the replicas, which are in a hash ring, we can see that all information is replicated onto 3 adjacent nodes, being those the ones taking participation on the quorum. Let's see a local first shopping list application you will absolutely want to use. Starting by registering 2 new users on the application, John and Mark. The accounts are created with unique IDs even for repeating names. Let's create a new list for John called Stuff. Don't worry because if you make a mistake because you can delete a list after creation. Going into the list, let's create our first item for a Christmas dinner. We will add 3 potatoes. The item was created successfully. We can reduce the quantity and also increase it. Let's create a second item that goes well with potatoes, ketchup. I just remember I already have bought ketchup last week. We can cross that of the list. Everything is being done locally, so we can reload the page and my list and contents will be saved. What if I want to log out and use the cloud storage as backup for my content? First let's sync our contents with the cloud for the first time. Now we can take our unique ID and log out. Logging back in, we get our lists back from the cloud backup so no information is lost. Let's now share John's list with his friend Mark so they can both collaborate on the shopping list at the same time. Now both Mark and John have the list and can work on it. Changes from one side can be synced and show at the other side anytime we want. For example, both users added 2 potatoes to the initial 5 and now both see 9 items to buy. Now let's both users will work in separate offline and make changes to the list needed for the Christmas dinner. After so many changes, let's sync everything back up. The individual lists have been merged into a single identical list equal on both users' sides. Let's now take a look at the admin control panel where we can see and control the active proxies, database replicas, where we can see the 3 nodes that stored our 6 commits, the hash ring and its contents, and see the active stored hints needed for handoff. Finally, there is also a manual garbage collection to condense the multiple agreed commit entries in the database into a single one. To show the resilience of the architecture, we'll kill one of the replicas currently storing the data for our shared list, replica 5002. Even with this momentary failure, the users won't notice a thing and can still commit changes and sync them up just fine. See, 11 potatoes on both sides. Now if we go back to the admin panel, we see that 2 of the replicas are indeed with 7 commits and the one killed didn't get the update. To the right, the hinted handoff table was updated to include data and metadata the failing replica has lost. If we turn the replica back on, the system will detect that change and will forward the handoff data to it, updating the commit entries count to 7. Finally, let's take a look at the garbage collection button. If we press it, a process will pass all replica commits and, in this case, the 7 commits present on the 3 replicas will be condensed to a single commit to avoid cluttering the replicas. This project provides users with a resilient local first shopping list application that supports live list collaboration for its users. Let's start preparing our next shopping list together.